to bring you back to what we did on Monday. All right. And I think it was Julia asked a great question. She's like, hey, how are we going to know how much to write? Because I'm not going to have in parentheses write 2 additional statements. Right. My answer is going to be it depends on what I'm asking. Okay. You are not going to write everything that comes to mind. That's not how the proofs work. All right. You're going to write what you need. And I hate to break it to you. I do have bad news right off the gun here today. Your knowledge here is not good enough. Like what you did for me on Monday, to do a proof is not good enough. And here's why. You need to take what you know, your vocabulary, all right, your definitions, and you need to connect them with kind of like some glue, all right, and put them in the right order. And what I'm going to show you today is the glue. All right, you guys have an extensive geometry vocab knowledge. We need to connect them somehow with some glue. And I'm going to show you 3 pieces of glue we can connect it with. And they are called properties or postulates. All right, so the first set, and I just want you to copy this part down here where it says equality postulates. This is what's going to go in our reasons column. Okay, this is what's going to go in the reasons column. All right, I'm going to show you 3 pieces of glue, 3 connectors today. And these connectors go into the reasons column. The first one is very hard for me to convince you that you're ever going to need it. All right, the first property is called the reflexive property. And if you read it, a quantity is equal to itself. Thanks for the breaking news, Mr. Carlino, huh? Wow. Wow. So you're telling me AB, segment AB is the same as segment AB. Woo. Angle B equals angle B. Mind blown, everyone, right? Mind blown. I promise you, before you walk out that door today, you're going to understand why you need it. All right. But for right now, just trust me. All right. That's going to be something we're going to use in the reasons column. You probably don't understand why right now, and that's fine. But by the time you leave that door, walk through that door today, I'll have you sold. So that's the first one. Back in your algebra days, what would you do with the 5? What would you do? Oh, you would replace it, substitute it in for x, right? Well, that's for algebra. We can do that for geometry. If 2 segments are equal, we can replace one for the other. If 2 angles are equal, we can replace one for the other. Take a look. I'm telling you that line segment AB is twice the length of line segment AD. I don't need a picture for this either. And I'm telling you AD and DB are the same length. Does anybody see any repetition of segments up there? Do you see any segments that repeat? I hope which segment repeats itself? AD repeats itself, right? So what I can do is, oh, wait a second. If AD equals DB, anywhere I see an AD, what can I replace it with? DB. And I believe I see an AD above, don't I? In the first statement. So what I can do is, yes, we can substitute it in and write a new true statement for number 2. So now for statement 2, okay, I'm going to replace AD with DB, and now AB is also equal to 2 times what segment? DB, yes. So we can do it also for in geometry using what's called substitution. That is called substitution. It is the same as substituting a number in for a variable, but now we're substituting in segment for segment. In a minute, we're going to do angle for angle. What I'd like you to do right now on your own with other people around you, I'm going to give you 3 true statements. A plus B equals 90. A equals C, B equals D. Can you write me 2 true statements now using substitution? Can you substitute in an equal into another statement? So I want 2 true statements right now using substitution. I know A plus B equals 90, but I bet there's a couple other angles added together equal 90. Can you give me one statement that's true because you substituted in an angle? Let's go here. Julia, give me one statement that's true.
Angle C plus angle D is 90.
There we go. Angle C. And I'm going to, just so I can write it in and go quick, I'm going to skip the measure part. A equal D equal 90. She actually did two substitutions there, right? She substituted in C for A and D for B. That's fine. Do two at the same time. I need another statement. Maybe you just did one substitution instead. You don't need to do both at the same time. We could have just done one substitution. And that, Jalen, your version here? Perfect job. Yep. If anybody had measure of angle C plus B equals 90, that's true too. All right, any questions? So I have reflexive, something's equal to itself, and now I have substitution. Kind of works like algebra now. We can do it for angles and segments. All right, my final one before we do our first proof. Just take a peek up here. If I had this rocking, I'm just gonna call this line segment A and line segment B. It has nothing to do with your notes. I just want you to lock in up here. If I told you this, what do you know about A and B? Same length, they're congruent because you know what hash marks mean. And then I'm gonna do this. And I'm gonna call these C and D. And I'm gonna tell you this. What did I tell you about C and D? They are congruent. What if I did this? I took A and I took C, put them together. I get a new line segment, right? That's longer than each of them. I put A and C together. And then I grabbed onto B, grabbed onto D, did the same thing. What do you know about my two new line segments? What should you know about my two new line segments? They're also the same length. Everyone agree with that? They are congruent. Now you could talk to me why, but the official way why they're congruent, if I took A and C and added them to B and D and the results are equal, that is called our third connector up here, which is addition. Okay? If you take two pairs of equal quantities and put them together, the results are equal. All right, so A equals B, C equals D. What I want you to write right now is give me a pair I could add together that would equal to the other pair added together. And I'll show you how we write this. All right, let me start with Cameron. Give me one pair you want to add together. Okay, ready? So A plus C, right? Show me you're adding them. Because if you write AC, you're showing me you're multiplying them. A plus C is the same as if we added what other pair up here? Let's go 10. Sophia? B plus D. Everyone agree when I add those together, those results are equal. That's called addition because you are adding. Is that the only thing I could have done? Any only thing? Anybody got any other pairs? If I added them together, they would also be the same? Maddie?
A plus D and C plus B.
Good. If I added A plus D, that's going to be the same length as C plus B. Good work. Great job. So we had reflexive, substitution, and now when we add equals together, the results are equal for addition. Take a deep breath, everybody. The moment is finally here. You are about to complete your first proof of your mathematical career. Huge moment. Huge moment right now. You don't think so, but it is. Huge moment. Also, probably one of about 150 we do, no exaggeration, this year. So this is one of many. All right, let me first set up what a proof looks like and what the goal is. I'm going to give you information like I did on Monday, right? Everyone sees my given information? What was the very first thing I asked you guys to do with the given information before you set up statements of reasons? Do what? Anybody remember from Monday? You read the givens and then mark the diagram if you could. I think you can mark your diagram. Go ahead. Mark your diagram that says AB equals DE and BC equals EF. We do not mark the proof statement. I'm going to tell you what that's all about in a minute here. Okay, do not mark the proof one. Just mark the givens, just like you did on Monday for me. So hopefully we have a set of hash marks here and a second set of hash marks on BC and EF. Perfect. Now does everyone see the proof? That's your goal. Tell me why that's true. All right, you know these pieces are equal, but I want the whole thing's equal. All right, that's your goal. Tell me why AC is equal to DF. All right, that is a proof. I will give you information. Using that information, you guys need to get that to be true somewhere. And you'll notice what we have set up are good old statements and reasons. What's the first thing I wrote in? What was the first thing you wrote in on Monday? Givens, right? Let's keep that the same. I apologize. I should have put number 1 there with the given. All right, we're not going to get there in one step, though. We're not going to get there in one step. So I need your help. What do I need to do to these 2 line segments to get to the bigger one? What do I need to do to these 2 line segments to get to the bigger one? What do I need? And don't just start spouting off some brand new stuff. Think about what we worked on today. All right, Natalie. I need to add them together, don't I? Does everyone agree? I got 2 small ones and I'm asking for a larger one. I need to add them. All right, whoop. Yes, I do need to add them. But you can't add unless you have how many pairs? How many pairs do I need? How many pairs did I have up here before we added? 2. You need 2 pairs to add. Look at my givens. How many did I give you? 2. So you're allowed to add in step 2. As long as you have 2 pair that you're going to add together, you're allowed to add right away. All right? So step 2 is going to be, tell us what you're adding together. What are you adding together? And now you got to get more specific here. You got to use your diagram and say, all right, I'm adding these 2 up because they're equal to these 2 added up. Name 2 segments we have to add up here to get to the big one. Shoom, where are we going with that one? Julia, which pair here?
AB plus BC.
Okay, everyone ready? So I'm going to take AB and add it to BC. And I'm going to set it equal to, because that's what addition is, set it equal to. Fiona? Which, no, not yet. You got to set it equal to the other pair I'm adding together.
Okay.
Which is what?
DE and EF.
Yep, I'm going to get to what you said in a second here. That's what addition is. When you add equal quantities to equal quantities, the results are equal. And again, that is called addition. It's kind of like the glue here that's going to put all this together, addition. You do not need to say postulate. If you want, that's fine. I don't require it. In a proof, the last step, the last statement in a proof should be your proof statement. That's when you are completely done. When the last statement is the proof statement. That is not my proof statement. That is not my proof statement, but we're going to make it into it. All right. And this is why I stopped Fiona before she said anything else. What is the same thing as AB plus BC? What could I put here instead of AB, right?
AB plus EF.
No. I don't want to change it. Because remember what I'm trying to get. I'm trying to get AC and DF. And if I put those together, I'm going to get a new segment. All right. AB plus BC. Look at your diagram. What's another name I could write there instead? Sully?
AC.
Everyone agree? If I take AB plus BC, that's another way of saying replacing it with AC. Equal to, do the same thing for DE plus EF. Instead of writing that, what could I replace that with, Michael? DF. I tried to give you a hint and yell it. I was replacing it with those. What did I just do there? I took AB plus BC and good. Substituted it in with something that it's equal to. This is substitution. Is that my proof statement? Is that my proof statement? Then we're good to go. All right, so I showed you what I'm adding. And then I replaced it with what it's equal to get to the proof statement. So that is why it's true. You add them together and you substitute in what it's equal for. Whoa. Embrace this. Embrace this. Quick story. Days before we had yonder pouches, I'd let kids take take out their phones and do a little selfie with their first proof. They post it on social media. They do a group picture, some pictures with their friends just to get the likes on the gram. All right, so if you want to go home tonight, all right, they're out there. Trust me, they're out there. You'll see a ton of pictures if you look at this time last year, I'm sure, with the kids I had taking selfies with their first proof. All right, it's a big moment. Okay, it's a big moment. Congratulations. You ready to do 149 more this year? Questions on this one? All right, we just did addition for segments. Let me show you how we can do a proof for angles. Okay, we can do the same thing for angles now. So first thing up, look at the givens, mark your diagram. Are we putting hash marks this time? No, what are we putting now? Mark marks, go ahead. I'm crossing my fingers, you guys know where these angles are. Again, only mark the given angles congruent. Do not mark the proof statement. That is not true. That's what we're trying to prove. I'm hoping nobody has issues marking these. So we should have a single pair of arc marks, double pair of arc marks. All right, take a peek. Make sure you got the correct angles marked. Okay, should be the ones right adjacent to each other. All good? Trace it with your pen. Remember, keep in mind, the middle letter is always the vertex of the angle. All right, the middle letter is always the vertex. So I know some kids might have marked these angles up here, but EF was never the middle letter. All right, so keep that in mind. All right, we ready? Look at the prove angles, the angles we need to prove equal. Don't mark them, but find them at least. Find them on your diagram. Angle ADC. Do you see that angle? Oh, it's right here. I don't need you guys to do it. I just want you to see it up here. There's angle ADC. And we need to prove that congruent to ABC, this angle right there. Okay, everyone see the smaller arcs you made? What do you do to those smaller ones to get to the bigger one? You gotta add. This is addition again. All right, tomorrow we'll do subtraction. It's all addition here because I'm going from these two smaller ones, smaller angles, to a bigger one. So I need to add together. All right, you want to add? You want to add? How many pairs do you need to add? Two. How many did I give you? How many did you mark? Two. So guess what? You can add right away. You just got to tell me what you're adding. You can add right away. That will not be the case, though, every time, though, that you can add right away. All right, give me a pair you want to add together or have to add together. Ryan, give me a pair you have to add together. Angle EDC has to be added with ADE, ADF, whatever you want to call it. Yep, same angle. We're talking the same language. Add those angles together, and that'll be the same if you added which other two together. Which other two do I need? Maddie?
CBE plus angle CBE
Yep.
plus angle ABF.
Good job. It works for segments and it works for angles. What's the reason why when I add two pairs of equal quantities, they're all equal? Addition. That's not my proof statement, so we are not done. But what happens? Give me another name for those two angles added together. Right? Sully, give me another name.
Angle ADC.
Yep, angle ADC. So I'm going to replace it with ADC. And that's going to be equal to, give me another name for these two angles added together. Those two angles added together, 1/6, Michael?
ABC.
ABC. And what did you and Sully just do there? You guys did. What did we add? We replaced it. We did substitution. And if you haven't picked up yet, yes, after you add, you will probably have to substitute immediately in the next step. That'll be the case all year long. This is fun. Just do addition, substitution. No, that's not how this works. And that's why I have example 3. Yeah, what's up, Sully?
Can you also say that like CDE is equal to C, like you could say like CDE is equal to CDF because E and F lie on the same line.
CDE and
CDF.
those angles?
Yeah.
Yeah, you're talking about the same angle.
Yeah.
You could, but it wouldn't get me to this.
Yeah, I know. But
Like, what you're just saying, instead of renaming it?
Yeah.
Yes.
Like
Yeah. It's like you can say CDE or you can say CDF. It's the same angle. Yes. Yep. All right, we ready? I wish it was this easy, right? Just do addition, substitution. All right. Notice anything right now? Only one given, huh? DE equals BF. That's the only given. Don't mark the proof statement. Don't mark the proof statement. Just mark DE congruent to BF. And does everyone see what I'm asking you to prove? DF, is that bigger than DE or no? Is DF bigger than DE? Yeah. Is BE bigger than BF? Yeah, I'm asking you this because I want you guys to realize I'm going smaller to bigger, which means I probably have to add on. Everyone agree? I got to add on. Ooh, problem. We didn't have this problem last 2. How many pairs do you need to add? 2. Oh, how many did I give you? Only 1. So we cannot add in step 2. Okay, we are not ready to add. We can't. We don't have enough information to add because I only have 1 pair. All right, so let me ask you this. Let's start with, I was going to be able to read that from back here. Let's start with DE. You need to go from DE to DF in the proof statement. And you guys said we need to add, so what do we have to add on to it?
Yeah.
EF? Yeah, everyone agree? I got to attach EF to it, yeah? Good? All right, we got to do EF. I'm just going to jot that down over off to the side. How do I go from BF to BE? Look at your diagram. How do I go from BF to BE on my diagram, Ryan? So we add the same segment to both of your guys' line segment? Yeah? Don't go by my tone. You're correct. Everyone, I got to add the same thing?
You're adding the same thing to 2 congruent parts.
Relax. Let me do the teaching. Is everyone on board with me? You got to add EF to both of these. What do you know about EF and EF?
They're the same.
Are they equal to each other?
Yep.
Because of? There it is. We need EF and EF are, look, ready? EF and EF are going to be our second pair. That's what I needed to add on to both. And the reason for it? Natalie. Reflexive. Thank you for saying it properly. It's not reflection. All right, there's no F in there. It's not reflection. Reflexive. Okay, guys, now how many pairs do I have?
2.
And now you can add them together. Okay? You can't add unless you have both pairs to add. And most of the time, that second pair might be a reflexive pair. The same pair. All right, so tell me what you want to add now in step 3 now, not step 2, step 3. Now we can add which pairs up here? 1, 5. Isabella, what do you want to add now? With? Yep, and that's going to be the same if you added what? Perfect. Addition. And then what always comes after addition? Substitution. Yep, substitute in what it's equal to. So DE plus EF is the same as DF. And BF plus EF is the same as BE. Substitution. Do not add until you have two pairs to add together. If you only have one, find the other pair. Everyone good there? All right, let's go to the homework. Let's go to the homework because we have plenty of time to start that. Just so we know, we are okay with the directions, numbers 1 through 4. All you're doing is writing reflexive, substitution, addition. That's it. No statements, reasons. All good there. When you go to number 5, does everyone see the directions change to write a formal proof? That means statements, reasons, like we've been doing today in class. Every proof will not have addition in it. It may just be given substitution. All right? If you do not put pieces together, don't add. Every proof will not have addition in it. It might be 2 steps. It might be 3. It might be a 4-step proof. Okay? If you see repetition, hey, let me go back. If you see repetition in the givens, it's probably going to be an automatic substitution, 2 steps. All right? So look for those look for the repetitions. Work with other people if you'd like. Call me over if you have questions. But once you start with number 5, start putting